Good day everyone, I'm here to discuss about concrete testing curing. The objective of this report is firstly to define what is concrete and its importance, to understand curing, and last but not the least, to identify concrete curing tests, standards, and specification. So, para mas madali nating maintindihan, ito yung organization ng aking topic. So, hinati ko siya sa apat. Unang-una is the brief history of concrete. Pangalawa is the definition of concrete and curing. Pangatlo is the ASTM C31. And last but not the least is the concrete mix proportion and design. So, dumako na tayo sa ating unang topic, which is the brief history of concrete. Bago pa mag 3000 BC, yung ancient civilization is gumamit na ng paste-like materials or specifically burnt limestone. So, sabi dito sa aking research, the first concrete-like structures were built by the Nabatea traders na discovered nila yung advantage ng hydraulic lime. Ito yung cement na nagha-harden underwater. The Nabatea understood the need to keep the mix as dry or slow lump as possible, as yung sobrang water, nag-i-introduce siya ng voids at nag-weaken ng concrete. Start na tayo sa ating timeline. Around 3000 BC, kung saan yung mga ancient Egyptians ay gumamit ng mud na hinaluan nila ng straw para mag-form ng bricks. So, mas similar to sa adobe kaysa sa concrete na kilala natin. However, dito, gumamit sila ng gypsum at lime mortars para sa kanilang mga pyramids. Second is the Great Wall of China. Ang ginamit naman dito sa kanilang cement is the glutinous sticky rice. So, some of these structures have withstood the test of time and have resisted even modern efforts of demolition. Diba? Hanggang ngayon, nakatayo pa rin yung Great Wall of China. Next is the Romans. So, in 82 AD, natapos nila ang Colosseum. At from 117 to 125 AD is the Pantheon. So, dito, na-discover nila yung Pozzolana and Arena Fossicia. Yeah, that's what they call it. So, these two react chemically with lime and water to hydrate and solidify into a rock-like mass that can be used under water. The Romans also used this material para mabuild yung large structures nila, such as the Roman baths, the Pantheon, and the Colosseum. Sinabi ko nga kanina. So, these structures still stand today. Napakatibay niya. As admixtures, they use animal fat, milk, and blood. Yes, kasama yung dugo. So, they use that as admixture materials that reflect very rudimentary methods. Okay, moving on, 476 AD, nagkaroon ng fall of the Roman Empire, Dark Ages. Ito ay mga panahong nawala yung Roman recipe para sa concrete. And next is 1793, si John Smeaton. Ito siya ay nag-create ng hydraulic cement. So, noong 1793, nagawa yung Eddystone Lighthouse sa Cornwall, England. FYI, nga pala bago ko makalimutan, base sa aking research, si John Smeaton daw ang father of civil engineering. 1824, Joseph Apstein, siya yung gumawa ng Portland cement. And after that, 19th century, nagkaroon ng mga strength testing or reinforcement sa mga concrete gaya ng steel mesh or enforcement with iron bars. So, 1891, si George Bartholomew. Siya yung unang nag-pour ng first concrete street sa US and it still exists today. So, sabi dito, 8,000 pound per square inches o PSI, which is twice the strength of modern concrete used in residential construction. Ang strength ng concrete na pinor ni George Bartholomew. In 1903, Ito yung first concrete high-rise building na patayo ito. So, yung first concrete high-rise building, ito ay kinonstruct sa Cincinnati, Ohio. It stands about 16 stories or 210 feet tall. In 1908, first concrete homes na nasa Union, New Jersey. It was designed and built by Thomas Edison. Siya din yung gumawa ng light bulb. In 1913, Baltimore, dito naganap yung first ready-mix delivery. In 1930, nagkaroon ng mga air and training agents. Ito yung nakatulong para sa resistance to damage from freezing and thawing. In 1936, nabuo ang ating Hoover Dam. Ang sabi dito, siya yung pinaka-large concrete project ever completed at that time. 1970s, fiber reinforcement is a method to strengthen concrete. FRC, fiber reinforced concrete, ito yung nagko-contain siya ng or dinadagdagan natin ng fibrous material para i-increase yung integrity ng concrete. Ang mga hinahalo dito, example niya is steel fibers, glass fibers, synthetic fibers, and natural fibers. So, ang pagka-add natin ng fiber sa concrete, the goal is not to add strength, but to prevent it from cracking, drying, or plastic shrinkage. So, fiber added to concrete, kaya nitong bigyan ng concrete ng better impact resistance and tensile strength. Inuulit ko, they don't necessarily make the concrete stronger with respect to flex 1. Inuulit ko, they don't necessarily make the concrete stronger with respect to flexural strength. And nung modern era, nagkaroon ng cut rate production. So, parang nangyari dito, na-compromise yung concrete. Kaya nagkaroon tayo ng mga inferior concrete. Siyempre, magkakaroon ng mga potential improvements for concrete maintenance and production. Okay, next slide. Yan, the definition and importance of concrete. So, ito yung concrete. Marami siyang pwedeng paggamitan. Kaya sabi dito, ito ay mixtures ng cement, aggregates, water, and admixture. So, it came from the Latin word concretus, which means compact or condensed. So, ang importance nito, marami siyang pwedeng paggamitan because of its remarkable trait. It's plastic and malleable when newly mixed, pero strong and durable when hardened. So, these qualities explain why this material can build skyscrapers, bridges, sidewalks, superhighways, houses, and dams, and other structures. So, marami siyang properties that make it suitable and the most popular construction materials. Gaya nga ng sinabi ko kanina, it is composed of cement, coarse aggregate, less fine aggregate, water, and chemical admixture. So, in simplest form, concrete is a mixture of paste and aggregates. Paano nga ba nagha-harden at nag-gain ng strength ang ating concrete? This is through a chemical reaction called hydration. Yan, itong hydration na to, may kinalaman pa sa curing. So, this chemical reaction called hydration is the key to achieving a strong, durable concrete aside from the careful proportioning and mixing of the ingredients. So, balikan lang natin konting review. Aggregates, these are crushed rock, gravel, sand, broken brick, or crushed air-cooled blast furnace slag. So, karaniwan, ito ay 60 to 75% of the total volume of concrete. So, natin sa dalawa, coarse aggregate and fine aggregate. Next up is yung ating paste. Ito na yung Portland cement, and yung ating water. Okay, definition of curing na tayo. Ano nga ba ang curing? So, copyright. According to Tyler Lay, isa siyang vlogger sa YouTube. So, curing is holding moisture or heat while hydrating. Ito din yung protecting the surface of our concrete. Ang nakalagay sa PPT natin, ito yung maintaining adequate moisture in concrete within a proper temperature range in order to aid cement hydration. Ano nga ba uli ang hydration? Ang hydration, siya yung process or chemical process na hinahayaan ng concrete na mag-gain ng strength para mag-harden ito. So, after all the concrete finishes or the concrete job, it is not yet done. So, yung concrete kapag ilagay mo na patag mo na, it's like an open wound. It can crack or be damaged. It is something that we need to protect. So, what do we do with an open wound? We put a band-aid on it. So, what do we do on the concrete? We cure it. So, adding water and putting a cover to hold the water, this is curing. So, makikita niyo sa picture, nag-a-add ng water. And sa pangalawa is tinatabunan nila ng material para ma-hold yung water. So, former chair of the ACI, which is American Concrete Institute, David Sikorski, if it dries, then it dies. So, tama nga ito. So, if our concrete dries out, it stops. So, no more hydration process, no more hydration product. So, it doesn't reach its potential. If you have good curing, so, syempre maganda din yung hydration product mo. So, if I have good curing, hydration products grow and make a tight structure. So, punta na tayo sa importance ng curing. Unang-una, it retains moisture in concrete for proper hydration. Para yung concrete natin, maging niya yung sufficient compressive strength. And second, it protects the surface of the concrete. Yan, kagaya nga ng sinabi ko kanina, concrete gain strength through hydration. Ni-reiterate lang dito. Hydration, ito ay chemical reaction between the cement and the water that results in the formation of various chemical contributing to setting and hardening. So, according to ACI, nabanggit ulit siya, which is the American Concrete Institute, it recommends the minimum curing period corresponding to attaining 70% of the compressive strength of concrete. So, it is often specified na ma-achieve yun after 7 days of curing. Pero 70% can be reached quicker when, syempre may dalawang factor, concrete cures at higher temperature, or certain admixtures are used. The ideal curing temperature is said to be 20 degrees Celsius or 68 degrees Fahrenheit. Since we're talking about curing and hydration, sa mga pinakamahalagang component nito is water. So, yung water, siya yung nag-a-act as lubricant or pampabasa for the fine and porous aggregate. Kaya nga sabi din dito, it is used for curing. So, less water in the cement paste will yield a stronger, more durable concrete. Kabaliktaran naman nun kapag mas maraming tubig. So, it will give a more free-flowing concrete with higher slump. May apat akong binigay or gustong emphasize, which is the strength, durability, versatility, and the environmental importance. Unahin natin sa strength. Diba, ang concrete natin, it can withstand tensile and compressive strength. So, yung strength nito na bumodify sa pamamagitan ng changes sa proportion in the mixture. So, concrete can increase in strength over time. And next is the durability. So, concrete can last for ages. Diba nga, Gaya nga sa history, na hanggang ngayon, nag-e-exist pa rin yung mga structures na ginawa ng ancient civilization. Versatility. So, marami siyang pwedeng gamitan. Sabi nga sa PPT, it has applications in different type of construction. And last but not the least is its environmental importance. So, sabi dito, it has numerous environmental benefits. So, it is so durable. It can survive natural disaster like floods. Secondly, it can be recycled and reused, which increases its lifespan even further. And last but not the least, minimal transportation is required for the raw materials. Next up is the ASTM C31. I'm just gonna give a short introduction kasi ang magdi-discuss nun is yung iba kong mga kagrupo. ASTM C31, standard practice for making and curing concrete test specimens in the field. So, this is a test required para makapasok ka sa American Concrete Institute Field Technician Certification Program. So, kapag ikaw ay isang concrete field testing technician grade 1, ikaw ay isang individual na may sapat na knowledge and ability para ma-perform mo ng ayos yung test at ma-record mo yung result ng 7 basic field tests on freshly mixed concrete. This program requires a working knowledge of the following ASTM test method and practices. Una, syempre, yung temperature of freshly mixed hydraulic cement concrete. Pangalawa is yung sampling ng freshly mixed concrete. Pangatlo is the slump of hydraulic cement concrete. Pang-apat is the density or unit weight, yield, and air content of concrete. Panglima is the air content of freshly mixed concrete by the pressure method. And last but not the least is the air content of freshly mixed concrete by the volumetric method. So, para dito sa test na to, magkakaroon ng concrete cylinder samples. Ito ay ginagawa ng ating lab technician to break in a hydraulic press machine para malaman ang kanyang compressive strength. On concrete mix ratio. Review lang natin yung tinalakay natin kanina. So, to make concrete, may 4 basic materials tayo. Unang-una is yung cement, aggregate. Sa aggregate, kasama na yung fine and coarse aggregate, water, and admixture. So, this concrete mixture ratio of a 1 part cement, 1 part sand, 3 parts aggregate will produce a concrete mix of approximately 2,500 to 3,000 PSI. Sabi din dito, yung strength properties ng concrete, inversely proportional siya sa water-cement ratio. So basically, it means that the more water na gamitin mo sa mix, the weaker the concrete mix. Kabaligtaran nun, the less water, mas stronger yung concrete mix. Type of concrete mix ratio as per IS code 456-2000. Ito yung 3 different part of concrete mix ratio. Unang-una is yung nominal concrete mix ratio. That is from M5 to M20. Pag sinabing M5, ibig sabihin, compressive strength niya or yung grade niya is 5 MPa. So, makikita niyo dyan yung table natin. So, concrete mix formula, example, yung M15. Ang concrete mix ratio niya is 1 part cement, 2 part sand, and 4 part aggregate. Ito yung standard concrete mix ratio. So, ito yung safest bet for any concrete mix. Ito ay yung 4-2-1. So, 4 part crushed rock, 2 part sand, and 1 part cement. Next is the high strength concrete mix ratio. Ito na yung pang mga mataasang strength. We have M50 to M70. The grade is generally denoted as M30. Ibig sabihin, yung compressive strength nito is 30 megapascal or 30 MPa. So, the grade of the concrete is very much likely nakadepende sa ating mix proportion other than the workmanship sa site. So, sabi dito, concrete mixing can be done manually para sa mga maliliit na project. Para naman sa mga malalaki, may mga ready-mix concrete tayo. So, that's the end of my report. Thank you for listening.
Hi, good day. Talking about the preparation and making of test specimen, we will talk about the significance and use according to ASTM C31/C31M-19A. The standard practice for making and curing concrete test specimens according to ASTM C31 provides standardized requirements for making, curing, protecting, and transporting concrete test specimens under field conditions. It includes the apparatus needed, the standardized process in making the specimen, the temperature to be obtained, as well as the duration of curing and transporting the concrete test specimens. According to ASTM C31, there are two curing conditions. The first one is the standard curing and the second one is the field curing. So standard curing, ini-store yung mga test specimens sa curing tanks, and the standard temperature and relative humidity is nakapaloob naman sa ASTM C511. Sa relative humidity, dapat greater than siya sa 95%, and yung standard temperature dapat is 23 plus or minus 2 degrees Celsius. And yung resulting strength test data na ma-observe sa standard curing is magsaserve ng following purposes. The first one is acceptance testing for specified strength. The second one is checking adequacy of mixture proportions for strength. And the third one is the quality control. Under field curing condition naman, it subjects the test specimens to the temperature and humidity that the actual structure experiences. So, dun mismo siya sa field ginagawa para malaman or matest yung strength niya accordingly sa temperature and humidity na ma-experience ng mismong structure. And yung resulting strength test data naman niya is magsaserve ng following purposes. So, yung una is determination of whether a structure is capable of being put in service. Second one is the comparison with test results of standard cured specimens or with test results from various in-place test method. The third one is the adequacy of curing and protection of concrete in the structure. And the fourth one is the form or shoring removal time requirements. After learning about the significance and use of the standardized practice in making and curing concrete test specimens, now we will talk about the apparatus and equipment that are used in making concrete test specimens. First one on the list is the molds. It comes in various shapes and sizes like cylindrical and cubic in shape. So it holds the test specimen to dry, shall be made of steel, cast iron, or other non-absorbent material and non-reactive material, and shall be watertight. So bakit nga ba siya kailangan gawa sa non-absorbent material? Para hindi ma-absorb ng molds mismo yung concrete test specimens, hindi didikit sa kanya. And dapat watertight siya kasi 'di ba minsan diba kapag fresh pa naman yung concrete mixture is mamasa-masa pa siya. So, dapat watertight siya para hindi madadrain yung tubig dun sa mismong mixture. And usually kasi kapag pinatuyo siya or yung mismong lagay na yun or yung mold na yun is pinagdidikit lang ng mga clamps. Para kapag tuyo na yung concrete test specimen is tatanggalin lang yung mga clamp para buong buo pa rin yung concrete test specimen. Hindi yung ihuhuhu mo yung specimen kasi masisira yon. So, under molds, we have cylinder molds. So, yung standard na height and diameter ng cylinder molds is nakapaloob sa ASTM C470. So, yung height niya is 300 mm and yung diameter niya is 150 mm. Height shall be twice the diameter. Yun yung standardized na cylinder molds. Second type naman ng molds is yung beam molds. Maximum variation from the nominal cross-section shall not exceed 3 mm or 1/8 inch for molds with depth or breadth of 150 mm or 6 inch or more. So yung length niya at least 50 mm or 2 inch greater than 3 times the depth. And yung ratio dapat ng width to depth is not exceeding 1.5. So mold should produce specimen at least as long but not more than 2 mm or 1/16 inch shorter than the required length. So the second one is the tamping rod. It is used to tamp fresh concrete into the molds to eliminate voids and excess air. So a round, smooth, straight steel rod with a diameter conforming to the requirements in the table. Dun sa table below, makikita niyo yung tamping rod diameter requirements according sa cylinder or width or beam at saka yung sa diameter or rod, millimeter or in inches. So, saan nga ginagamit yung tamping rod? Ginagamit siya kapag nilalayer yung fresh concrete dun sa mold. So, kapag nilagay na or na-layer na yung fresh concrete dun sa molds, tinatamp siya para mawala or masiksek yung concrete or fresh concrete at matanggal or ma-eliminate yung mga excess air and voids. Nabanggit ko kanina na yung molds comes in various shapes and sizes. Ngayon, yung size ng molds doon nakadepende kung gaano ba kahaba yung length ng tamping rod na gagamitin mo at saka yung diameter. So sa length, at least 100 mm greater than the depth of the mold in which rodding is being performed, but not greater than 600 mm in overall length. Tapos yung length naman na 400 mm to 600 mm, pinapalo naman yung practice ng ASTM C31, C31M, at saka yung mga test methods listed below. The third one naman is yung concrete vibrators na nagsaserve ng same purpose like the tamping rod. So it is used for removing air void from concrete mass and prevent from formation of honeycomb. So sa paggagawa kasi ng concrete test specimens or sa concrete mixture kasi kapag binubuhos, it's either by tamping or by vibration para matanggal yung mga excess na voids and air. So sa concrete vibrators, at least 150 Hz or 9,000 vibrations per minute while the vibrator is operating in the concrete. So, kadalasan din na makikita na ginagamit siya dun mismo sa field kapag nagbubuhos na ng concrete mixture. So, diameter of a round vibrator shall not be no more than 1/4 of the diameter of the cylinder mold or 1/4 of the width of the beam mold. The fourth one naman is yung mallet or a type of hammer. It is used to tap around the mold for compaction of concrete test specimen. Made with a rubber or rawhide head weighing 0.6 plus or minus 0.2 kg or 1.25 plus or minus 0.5 pounds. So, mamaya ipapakita ko naman sa inyo kung paano ginagamit yung mga aparatos na to sa paggagawa ng concrete test specimen. So, sa mallet naman, pinupukpok kasi yung gilid ng cylinder molds or ng molds na ginamit para masiksek yung mga fresh concrete mixture. The fifth one naman is finishing tool. It is handheld float or a trowel used to level off the specimen before closing the lid. Pinapantay lang niya yung ibabaw ng molds na pinaglagyan ng fresh concrete para pantay na pantay bago saraduhan and i-cured yung concrete test specimen.
You can use 4x8 or 6x12 cylinder molds. The 4x8 cylinder molds you'll fill in 2 equal lifts by volume. 6x12s, you'll fill 3 equal lifts by volume. So as we begin filling the mold, we'll fill it halfway. We'll rod it 25 times with a 3/8 rod. You can use your open hand or you can use a mallet to consolidate. Second lift. We'll completely fill the mold. Slight overfilling is appropriate. Rod throughout this depth, penetrating the lift below. After that's completed, you'll strike off the top of the mold. You can use your rod, a handheld float, or a trowel. Clean off your excess. You want to protect it from any evaporation. Molds with plastic lids. Just seal the lid. Make sure that you mark your cylinder and transport it to the place of initial curing.
The sixth one naman is yung slump apparatus. Shall conform to the requirements of test method C143, C143M, and yung metallic mold dapat gawa siya sa 20 cm diameter na bottom, 10 cm diameter yung top, and yung height niya is 30 cm. So, yung slump apparatus kasi ginagamit naman siya para dun sa slump test or tinetest kung tama ba yung ratio ng concrete mixture.
First thing you want to do is make sure that your slump cone is moist both inside and out. You want to perform this test on a flat, smooth, rigid surface free of any vibration. And it needs to be a non-absorbent surface. The cone will be held in place. You can stand on the ears or you can use the slump place and lock them into place. We'll fill the cone, 3 equal lifts by volume, rotating the concrete around the mouth of the cone to evenly distribute it. I'm going to rod this lift throughout its depth without forcibly striking the bottom. Half of my roddings are going to be at an angle to ensure that I get proper penetration into the corners. The rest will be across the cross section. Second lift, we'll fill the mold to 2/3 by volume. We'll rod this lift throughout its depth, penetrating the lift below by approximately 1 inch. Third and final lift, we'll completely fill the mold. We'll rod this lift throughout its depth, penetrating the lift below by approximately 1 inch. If at any time the concrete falls below the lip of the mold, you'll add a representative portion of concrete back into the mold and begin rodding where you left off. With a rolling, screeding action, you'll strike off the top of the mold. The tamping rod is the only approved method for striking off the mold. Remove any excess concrete. We're going to raise the mold in 5 ± 2 seconds, clearing the concrete slump by 12 inches. You don't want any torsion or side-to-side movement as you raise this mold. We'll invert the cone, measure down to the offset center, and get your reading for your slump.
The seventh one naman is yung air content apparatus. The apparatus for measuring air content shall conform to the requirements of test method C173, C173M, or C231, C231M. So, dinedetermine niya yung air content ng normal weight concrete. Pinipill up yung container na makikita nyo dun sa baba. And pinipill up siya, kagaya lang ng pagpipill up ng fresh concrete dun sa molds. And tinatamp din siya 25 times kapag nile-layer. So, kapag na-level off na yung fresh concrete dun sa container, tinataklo ba na siya or kino-close na siya gamit yung gasket and cover assembly. And tinetest ngayon yung air content nito by pressure method. Last one naman is yung temperature measuring device. Siyempre, ginagamit siya para ma-measure yung temperature ng concrete mixture para masigurado na tama lang yung temperature niya para matuyo at ma-cure properly. So, it shall conform to the applicable requirements of test method C1064 or C1064M. So, that's the end of my report. Ang next naman na magre-report is si Mark James Niebla. Thank you!
Good day everyone, so I'm Mark James Niebla, and for the next topic I'm going to discuss about the testing requirements and procedure in making a concrete test specimen. So first is the testing requirements. So dito malalaman natin yung mga required sizes, lengths, and other specification ng ating mga specimen. So let's start. So, ang una natin is the cylinder specimen. So, ang cylinder specimen is ginagamit natin for the compressive strength test. So, ang ating cylinder cast daw is dapat ay allowed to set in an upright position. Then, ang bilang or the sizes ng ating cylinder is nakadepende sa ating specifier ng ating test. Then, next is yung length ng ating cylinder is dapat twice siya ng ating diameter. So, kung ang ating diameter ng ating cylinder is nasa 150 mm, so ang ating length ng ating cylinder is 300 mm. So, next is cylinder diameter should be at least 3 times the nominal maximum size of aggregate. So, dapat yung ating diameter ng cylinder is at least 3 times siya na mas malaki doon sa ating nominal maximum size ng ating aggregate. So, next is kung ang nominal maximum size natin is nag-exceed ng 50 mm or 2 in inches. So dapat siyang i-treat natin sa wet sieving through 50 millimeter sieve. Then for acceptance testing for specified compressive strength, so ang ating cylinder is dapat ay 150 millimeter, 150 by 300 millimeter, or in inches 6 by 12, or 100 by 200 millimeter, or 4 by 8 in inches. Then next is punta naman tayo sa ating beam specimen. So kung ang cylinder specimen natin is ginagamit for the compressive strength test, so ang beam specimen natin is ginagamit naman sa flexural strength test. So yan, flexural strength specimen should be beams of concrete cast and hardened in the horizontal position. Then yung length ng ating beam specimen is at least 50 millimeter or 2 inches, greater than 3 times the depth as tested. Then yung ating ratio ng width to depth is molded shall not exceed 1.5. Then next is the minimum cross-sectional dimension of the beam should be as stated in table 2. So tignan naman natin yung ating table 2. So ito yung ating table 2, the minimum cross-sectional dimension of the beam. So nominal maximum aggregate size or NMAS. So kung ang NMAS natin is less than or equal to 25 millimeter or 1 inch, is ang minimum cross-sectional dimension natin is 100 by 100 millimeter or 4 by 4 inches. Then kung ang NMAS daw naman natin is greater than 25 millimeter but less than or equal to 50 millimeter, so ang ating minimum cross-sectional dimension is nasa 150 by 150 millimeter or 6 by 6 inches. So next is balik naman tayo. So unless the otherwise specified by the specifier of the test, the standard beam should be 150 by 150 millimeter or 6 by 6 inches in cross section. So kung hindi naman in-specified ng ating specifier yung gagamitin nating beam specimen, so ang gagamitin nating size is yung standard size ng ating beam specimen, which is the 150 by 150 millimeter or in inches 6 by 6. Next is when the nominal maximum size of the coarse aggregate exceeds 50 millimeter, the concrete sample should be treated by wet sieving through a 50 millimeter sieve. So kagaya din nung sa ating cylinder specimen, so kung nag-exceed yung ating nominal maximum size to 50 millimeter or in 2 inches, so yung iti-treated natin ulit siya sa ating wet sieving, so through a 50 millimeter sieve. So next is the specifier of the test shall specify the specimen size and number of specimen to be tested to obtain an average test result. So ang ating specifier is dapat specify yung mga specimen sizes and yung mga bilang na ating yung mga kung gaano kadami yung ating gagamiting specimen for the testing. Then next is the same specimen size should be used when comparing results and for mixture qualification and acceptance testing. So kung ano yung ginamit nating mga sizes sa ating specimen, so dapat pare-pares lang yun. So para ma-compare natin yung mga results and kung ano yung mga dapat na gamitin for the mixture ng ating concrete. And lastly, for the testing requirements is the field technician. So kung meron tayong mga specimen, may mga materials tayong ginagamit for our testing, so kailangan din natin ng maggagawa or magkakonduct ng ating testing, so which is the field technician. So ang field technician ito yung gumagawa or nag-procure ng ating mga specimen or nagkakonduct ng ating mga tests. So itong field technician may qualification requirements din silang minimit for this practice. So qualification yan. So, all relevant testing services are provided under the full-time technical direction of registered professional engineer with at least 5 years experience in construction materials testing. So, dapat ay merong 5 years experience in construction material testing. Then, ang ating supervising laboratory technician and supervising field technician should possess a minimum of 3 years relevant experience and current technician certification. So, kailangan ang ating supervising laboratory technician and supervising field technician is dapat may at least 3 years na experience na sa construction material testing and meron silang current technician certification. Then, for our concrete laboratory technician, aggregate laboratory technician, and concrete field technician is dapat ay meron silang current technician certification. Then next naman natin is the procedure. Procedure in making our concrete test specimen. So, ang una natin is sa paggagawa ng ating specimen is meron tayong general procedure. So, ang una daw is obtain the sample according to the FOP for WAQTCTM2. Then, next is kung ang diameter daw na ang ating specimen is 150 mm or in 6 inches. Then, meron daw siya nominal maximum size na greater than sa 50 mm or 2 inches. So, required siya na magkaroon ng wet sieving per the FOP WAQTC TM2. Then, after that is screen natin yung sample over the 50 mm sieve. Then, next is remix the sample after transporting to testing location. So, after ma-transport sa ating testing location, so, i-remix na natin yung ating sample. Then next is begin making specimens within 15 minutes of obtaining the sample. Then next is set molds upright on a level, rigid face in a location free from vibration and relatively close to where they will be stored. So, dapat yung ating daw molds is nakastore siya sa rigid base kung saan hindi magagalaw or free siya from the vibration. So mas safe na paglagay natin is yung ating lapag. So, kung gagawa tayo or mag-make na tayo ng ating specimen. So, yung molds natin is mas maganda na sa lapag or dun sa place na kung saan is hindi siya magagalaw. So, next naman is fill molds in the required number of layers, attempting to slightly overfill the mold on the final layer. So, yung next naman daw natin is pag-fill ng ating molds. So, merong required number of layers na ginagawa or ginagamit for filling our molds. So, merong 3 layers or meron ding 2 layers. Depende sa ating molds na ginamit, sa size ng molds na ating ginamit. So, next is add or remove concrete prior to completion of consolidation to avoid the deficiency or excess of concrete. So, pwede tayong magdagdag or magbawas ng ating concrete depende sa completion ng ating consolidation para maiwasan yung pagkasobra or pagkakulang ng ating concrete. So, mamaya mas madidiscuss pa natin yung pag-fill ng ating molds in the other procedure. So, next is there are 2 methods of consolidating the concrete. So, meron daw 2 methods in consolidating the concrete. So, yung dalawang yun is the rodding and the internal vibration. So, kung ang ating slump daw is greater than 25 mm or 1 inch, Yung consolidation na gagamitin natin is pwedeng rotting or vibration. So, kung ang slump naman daw natin is 25 mm or less than 25 mm, so yung sample natin is pwede natin i-consolidate by the internal vibration. So, yung agency specification may dictate when rotting or vibration will be used. So, next naman natin is making cylinders. So, di ba meron tayong two methods of consolidation? So, una nating i-discuss is about the rotting. So, sa paggawa ng ating cylinder, na ginagamitan natin rotting. So, una daw is para sa ating standard na 150 mm by 300 mm or 6 by 12 inches na specimen is i-fill natin yung ating mold into 3 approximately equal layers. Then, sa atin namang 100 mm by 200 mm or 4 by 8 inches specimen is i-fill natin yung mold natin ng 2 equal layers. So, sa pag-fill ng ating mold, so i-distribute natin yung ating concrete sa ating molds around the perimeter. Then, sa ating mga final layer is slightly overfill natin siya. Then, next is consolidate each layer with 25 strokes of the appropriate tamping rod using the rounded end. So, each layer, so, itatamp natin yung ating specimen na 25 strokes by the use of tamping rod. Then, distribute strokes evenly over the cross-section of the concrete. Rod the first layer throughout its depth without forcibly hitting the bottom. So, kada layer is, yun nga, itatamp natin siya ng 25 strokes. Then, paikot yon, circular motion sa ating specimen. Then, dapat iwasan natin na maabot natin yung pinaka bottom ng ating molds, then yung sides ng ating molds. Then ganun din sa ating sa second layer naman. So sa pagtatamp ng ating specimen is dapat hindi natin magagalaw or maabot yung ating first layer. So ganun din sa ating final layer. So dapat sa pagtatamp natin is dapat hindi rin maabot yung ating second layer. So for subsequent layers, rod the layer throughout its depth, penetrating approximately 25 mm or 1 inch into the underlying layer. So, dapat approximately na 25 mm yung distance niya. So, pag tayo nagtatamp ng ating specimen, each layer. The next is, after rodding each layer, so tap the sides of each mold 10 to 15 times with the mallet or lightly with the open hand. So, di ba, after rodding our specimen each layer, so pagka-rod natin nun is itatamp natin yung sides ng ating molds by the use of mallet. So, itatap natin siya ng 10 to 15 times. So, para na-distribute or ma-fill natin yung mga voids dun sa ating specimen or dun sa concrete. Then, lastly, strike off the surface of the molds with damping rod or straight edge and begin initial curing. Diba? Sa ating final layer is slightly overfill tayo ng ating concrete. So, isa-strike off na natin yun, then ipa-flatten na natin yung ating surface ng ating mold. Then, after that, pwede na tayo mag-start for our initial curing. So, bago tayo mag-next, is may papanood muna akong video about this. So, para mas mag-gets or mas ma-visualize nyo yung paggagawa ng ating specimen.
We have to put our concrete mixture inside our mold. So we have to put 3 equal layers of concrete mixture in our mold. After putting 1 layer, we have to use our tampering rod to tamp our mixture in circular motion 5 times. Then again, for the second time, we have to tamp our mixture. But be careful not to reach the first layer of our mixture. And that is how we prepare our concrete specimen for concrete cylinder mold.
So, yon. Then, dako naman tayo sa paggagawa ng ating cylinder by internal vibration. So, ang una daw is fill the mold in 2 layers. So, sa ating rodding, pwedeng depende sa ating specimen kung siya ba ay standard or 100 by 200 mm. So, kung magto 2 layers siya or 3 layers. So, pag internal vibration naman, so kailangan lang natin na i-fill yung mold natin in 2 layers. Then next is insert the vibrator at the required number of different points for each layer. So pag 2 points for 2 points daw for 150 mm or 6 inches in diameter cylinder. So 1 point lang daw for 100 mm or 4 inch diameter cylinder. Then, when vibrating the bottom layer, do not let the vibrator touch the bottom or sides of the mold. So, kagaya lang sa rodding, so dapat pag nag-apply na tayo ng vibration sa ating specimen or sa ating concrete is dapat hindi maaabot natin yung bottom part ng ating mold. Then, ganun din. Dapat is hindi rin matatouch yung or masasagasaan or yung sides ng ating mold. So, when vibrating the top layer, the vibrator shall penetrate into the underlying layer approximately 25 mm or 1 inch. Then, next is remove the vibrator slowly so that no large air pockets are left in the material. So, sa pagkatapos natin gamitan ng vibration, so, yung vibrator natin is dahan-dahan lang natin siyang tatanggalin. So, hindi magkaroon ng large air pockets sa ating material. Then next, after vibrating each layer, tap the sides of each mold 10 to 15 times with the mallet, or lightly with the open hand. So, agad din sa rodding, kada layer ng sa pagbabibrate ng ating material, so itatap din natin siya ng 10 to 15 times sa sides ng ating molds. Then lastly, strike off the surface of the molds with tamping rod or straight edge and begin initial curing. So ganun din, isa-strike off din natin and then i-flatten or yung surface ng ating molds. Pwedeng gamitin ang ating tamping rod. Then, after that, is pwede tayo mag-start sa ating initial curing. And then, next naman is for making our flexural beam in rodding. So, una is fill the mold into approximately equal layers, with the second layer slightly overfilling the mold. So, sa ating paggagawa naman ng ating flexural beam is dapat i-fill natin yung mold natin ng 2 approximately equal layers. So, sa ating second or final layer is slightly overfill ulit natin yung ating molds. Then, next is consolidate each layer with a tamping rod once for every 1,300 squared millimeter or 2 square inch. So, using the rounded edge. So, i-consolidate natin siya, each layer, in every 1,300 square millimeter. So, rod each layer throughout its depth taking care to not forcefully strike the bottom of the mold when compacting the first layer. Rad the second layer throughout its depth, penetrating approximately 25 mm or 1 inch into the lower layer. So, ganun din. Kagaya lang din ng sa cylinder. So, dapat sa pagrarad niya ng each layer is dapat hindi siya hindi niya matouch yung pinaka-bottom na molds and then yung sides. Then, sa pag-rad din ng ating second layer or the final layer is dapat hindi ma-reach yung ating bottom layer or the first layer. So, dapat meron siyang penetrating na approximately 25 mm or 1 inch. Then, next, after radding each layer, strike the mold 10 to 15 times with a mallet and spade along the sides and using a trowel. So, kagaya lang din sa mga nauna. So, after radding is kailangan din natin siyang i-tap yung sides ng ating molds. So, itatap natin siya ng 10 to 15 times with the mallet. Then, next is lastly is strike off a flat surface using a float or a trowel and begin initial curing. So, for the last procedure is dapat, diba nga nag-overfill tayo, so isa-strike off na natin yung pinaka sobra. So, and i-flatten natin yung surface ng ating molds. So, using a float or a trowel. Then, pwede na tayo mag-start for our initial curing. Then, para ma-visualize or para mas maintindihan natin yung procedure or para makita nyo kung paano ginagawa yung ating flexural beam by the radding. So, ipapanood ulit ako video.
Next, we'll have the preparation for the concrete specimen for beam. So we have here our concrete beam mold, our concrete mixture, used oil, and our tampering rod. So like the first procedure, we have to put 3 separate equal layers of concrete on our mold. So let's begin by putting our first layer. Now we will roll our tampering rod on top of our concrete mixture to avoid excess concrete. And that is how we prepare concrete sample for our beam mold.
So, and lastly, for our making flexural beams in vibration, so una is fill the mold to overflowing in one layer. So, kung sa ating paggagawa ng ating flexural beam in radding is 2 layers ang ginagawa. So, sa ating vibration naman is 1 layer lang. So, pero dapat overflowing pag-fill ng ating mold. So, next is consolidate the concrete by inserting the vibrator vertically along the center line at intervals not exceeding 150 mm or 6 inches. So, dapat is consolidate natin yung concrete natin by inserting vibrator vertically along the center line and not exceeding ng 150 mm or 6 inches. Then, dapat iwasan din natin siya na hindi mag-over-vibrate sa ating materials or magkaroon ng over-vibration. Then, sa pag-withdraw naman ng ating vibrator is dapat dahan-dahan lang natin siyang tanggalin sa ating material so para hindi magkaroon ng large voids. Then, kagaya lang din sa mga nauna, is dapat yung vibrator natin is hindi magkakaroon ng contact or hindi magta-touch sa ating bottom or doon sa sides ng ating molds. Then, next is after vibrating, strike the mold 10 to 15 times with the mallet. So, after vibration, so, strike lang natin yung sides ng ating molds na 10 to 15 times. Then, lastly is strike off to a flat surface using a float or trowel and begin initial curing. So, sa last step is dapat strike off na natin yung mga excess, then i-flatten na natin yung ating surface ng ating mold. So, using our trowel, then after that is pwede na tayong mag-begin for our initial curing. So, dun lang tatapos ang aking report. So, yun po.
Hello, good day everyone. I'm Mariel Nueva. Let's now discuss the concrete testing. Concrete testing, for the smaller residential concrete contractor, concrete testing may not be routine practice and even seem like an inconvenience. Dun sa mga smaller residential concrete contractor natin, hindi na sila nag-undergo ng concrete testing. But the relatively small cost associated with testing pays for itself rather quickly when problems or questions arise on projects. So, ang kahalagahan kasi nitong concrete testing is malalaman natin if ang concrete natin is pwede na natin siyang gamitin sa ating project, no, kung hindi magkakaroon ng problema. If tumigas ba tong concrete na to, hindi ba magkakaroon ng crack, or wala bang butas-butas to kapag pinuhos natin sa ating column or sa footing. So, yun yung kahalagahan ng ating concrete testing. And then, assessing the properties of fresh concrete during placement leaves the contractor in a better position to respond to any problems that ensue, such as low strength or cracking. So, if yung contractor natin is na-assess niya yung properties of fresh concrete, no, hindi na siya mangangamba if this concrete is magka-crack or magiging mahina kapag binuhos na sa ating column. So, may nag-undergo kasi tayo ng different testing dito sa ating concrete na i-discuss ko nga mamaya. And then, fresh concrete test data such as slump and air content can help indicate possible causes and guide the troubleshooting investigation. So, yun nga, one of the tests is yung slump and air content na i-discuss ko nga mamaya. And then the most frequently asked question dito sa ating concrete testing is, was excess water added? Was the air content too high or too low? So, malalaman natin yan mamaya. Next, testing fresh concrete overview. So, meron tayong sampling, which is the first step ng ating concrete testing. Temperature. So, kinukuha rin natin yung temperature ng ating concrete. Concrete slump test. Tinatest natin if yung concrete natin is magkakaroon ng slump. And then, air content, air and train concrete. So, tinitingnan din natin if yung ating concrete is may air content ba siya or yung may voids ba siya sa loob. And then, molding specimens, which is the requirements for molding test specimens. So, dako tayo ngayon sa ating sampling, which is the first step in determining if the concrete placed complies with specifications. So, dito natin malalaman if yung ating concrete is in standard ba siya. And then, the guidelines are to take composite samples of sufficient total volume, which is yung 1 cubic feet, and that is the minimum, from the ready-mix track after 10% and before 90% of the load has been discharged. So, kuha tayo ng composite sample ng ating concrete after mag-discharge ng ating ready-mix truck ng 10% niyang total volume. And kukuha ulit tayo ng another composite sample before mag-discharge yung ating ready-mix truck ng 90% ng kanyang load. So, these samples must be taken no more than 15 minutes apart. So, kailangan makuha na natin yung first and second sample nang hindi lumalampas ng 15 minutes. So, ganun siya kabilis. And remix to yield a composite sample. So, i-remix natin siya, yung dalawang sample na nakuha natin from 10% and then before 90%. Then, they are then covered to protect against rapid evaporation and to avoid contamination. So, i-cover natin siya kasi lalo na kapag nasa construction site tayo, no? May mga alikabok or pwede siyang mabasa ng ulan. So, i-cover natin tong ating composite sample na nakuha. Then next, after ng sampling, kukunin na natin tong temperature ng ating concrete na minix, no? So, start taking temperature measurements of the concrete within 5 minutes after securing the remixed composite. So, after ng haluin, isa-start na natin ikunin yung temperature ng ating concrete after 5 minutes natin siyang i-leave, no? After natin i-mix and then i-leave natin siya ng 5 minutes and then doon natin i-start kunin yung temperature. So the thermometer should be accurate to 1 degrees Fahrenheit. So ayan dapat yung thermometer na gagamitin natin. Accurate siya to 1 degrees Fahrenheit. And then the concrete should be in a wheelbarrow or other suitable receptacle that will permit insertion of the thermometer so that at least 3 inches of concrete surrounds the stem. So at least yung ating thermometer is kapag ilalagay natin siya dun sa ating concrete, dapat ilulubog siya at least 3 inches para malaman natin yung accurate na temperature ng ating concrete. As long as sufficient concrete surrounds the thermometer in your sample, it should remain inserted for a minimum of 2 minutes. So that is the minimum, 2 minutes lang, no? While the other tests are being conducted. Kasi habang tinatest natin tong temperature ng concrete, pwede na rin nating itest yung ating concrete for other testing. So after the 2 minutes elapsed, the test is complete once the reading remains stable to within 1 degrees Fahrenheit. So, malalaman lang natin na okay na tong concrete na to kapag ang temperature niya is naging 1 degrees Fahrenheit. Next, here the temperature is being taken after concrete placement. So, nakikita nyo naman po sa picture. But ideally, it should be taken prior to placement to respond to temperatures outside of a specified range. The thermometer is placed to provide at least 3 inches of concrete around the inserted stem. So sabi ko nga, kailangan nakalubog siya at least 3 inches yung ating thermometer. And left in place a minimum of 2 minutes. Gaya nga nasabi ko, ang minimum duration ng ating thermometer sa ating concrete is at least 2 minutes. And until the temperature has stabilized. Kapag ang temperature natin is naging 1 degrees Fahrenheit na. So temperature measurements can also be taken in the transporting vehicle. So pwede rin pala nating i-take yung temperature ng ating concrete kahit nasa transporting vehicle siya or within the forms as long as 3 inches of concrete surround the thermometer. Dapat talaga 3 inches yung nakalubog dun sa ating thermometer. At ang itsura ng thermometer for concrete is itong nasa right side, kung makikita nyo po. Ayan. And then, meron din tayong testing tip. So, a common mistake many people make is to remove the thermometer to read the temperature. Be sure to read the dial while the thermometer is still inserted into the concrete. So, kapag magre-read tayo ng ating temperature sa ating thermometer, i-read natin siya habang ang thermometer natin is nandun pa sa ating concrete. Hindi natin siya i-read after natin tanggalin dun sa concrete yung ating thermometer. So, it should be read habang nandun pa siya sa ating concrete. So, testing tip for taking the temperature of concrete. The next step is the concrete slump test. So, slump tests for ASTM C143 are applicable for concrete with slumps greater than 1/2 inch and less than 9 inches. Once the concrete sample has been remixed, start taking the slump test within 5 minutes. So, sabi ko nga kanina, no, habang tinitake natin yung temperature, pwede rin tayo mag-undergo sa another testing, which is pwede tong concrete slump test. So, habang tinetest mo yung temperature ng concrete, pwede ka rin mag-test ng concrete nito about naman sa slump test. So, sabi dito, start by filling a mold. So, yung mold natin is hugis cone. 12 inches high in the shape of the first room of a cone, yung nakikita nyo sa baba na drawing. Ganun po yung itsura nun. That is 8 inches in diameter at the bottom and 4 inches in diameter at the top. So, fill the mold in 3 equal layers by volume. So, magkakaroon tayo dito ng 3 molds or pwede rin 4, not by height. So, if i-fill natin to ng concrete tong ating cone, not by height but by volume. So, rod each layer 25 times. So, haluin natin using the rod 25 times with a bullet tip. So, dapat manipis talaga yung ating rod. 5/8 inch diameter rod to compact each layer. So, para ma-compacted natin yung ating concrete na binuhos sa ating mga molds. After filling and rodding, raise the cone to allow the concrete to subside. The distance the concrete subsides or slumps is based on its consistency. So, nakikita niyo sa picture sa baba, meron tayong true slump, zero slump, collapse slump, and shear slump. So after tanggalin yung mold, yung sa true slump nun, makikita nyo may konti siyang, ay hindi na siya kagaya dun sa shape nung ating mold. Bumaba siya, no? Meron na siyang lagpas konti dun sa ating mold. Kung makikita nyo dito sa drawing, dito sa true slump. And then sa zero slump, which is potentially non-plastic, ganito pa rin, kahugis pa rin siya ng mold natin, yung ating concrete, no? After nating i-remove yung mold, ka-shape pa rin siya ng ating mold. And then sa collapse slump naman, which is potentially non-cohesive, so hindi siya madikit, no? Hindi siya pwedeng gamitin. Ayan, kung makikita nyo sa picture, sobrang nag-collapse yung ating concrete. And then sa shear slump, no display center, kung makikita nyo is, ayan, nag-shear yung gilid ng ating concrete, nalaglag yung gilid nung sa right. So, pwede rin siyang sa left. So, tinatawag natin siyang shear slump. So, malalaman natin kung consistent ang ating concrete base dun sa nakita nating slump. So, kung nakikita nyo naman sa true slump, konti lang yung pagka-slump ng concrete. Dito naman sa zero slump, walang ka-slump-slump. And then sa collapse slump, sobrang daming lumagpas na concrete sa ating mold. And then sa shear slump, may naglumampas din. So, yun yung tinitingnan natin dito kung consistent ba yung ating concrete. So, yun yung kinocompute natin, yung slump ng concrete. Next is sa concrete slump test pa rin. Measure the amount the concrete slumps or settles from the original height of 12 inches to the nearest 1/4 inch and record as the slump in inches. So, nire-record natin kung gaano kalayo yung narating ng ating concrete base doon sa mold natin. And tinitingnan din natin kung same pa rin ba yung height ng ating concrete dun sa 12 inches na mold na pinaglalagyan niya after tanggalin yung mold. So the measurement is made between the original height of 12 inches and display center of the settled mass of the demolded concrete. If the test falls outside of the specified range, a check test is typically performed to confirm test results. So if nag-collapse nga yung ating concrete, gaya dito sa picture, nag-undergo pa siya ng check test, no, if totoo nga na yung ating concrete is nag-collapse kasi it's either nagalaw lang siya or mali yung pagkakatanggal ng ating mold. So, nag-undergo pa siya ng check test para ma-confirm yung test result. So, concrete slump test pa rin, meron tayong testing tip. Since concrete setting is time and temperature dependent, this test must be started within 5 minutes after obtaining the composite sample. Yung composite sample natin tinatawag is yung napaghalo nga nating first sample and second sample na kinuha natin sa ready-mix truck. So gagawin natin tong concrete slump test after 5 minutes natin siyang i-leave. So sabi ko nga kanina, pwede natin gawin tong concrete slump test habang ginagawa rin natin yung temperature test. And completed within 2.5 minutes after the filling process begins. So ganun kabilis dapat matapos yung ating concrete slump test, at least 2.5 minutes dapat tapos na siya habang kasama na yung pag-fill ng concrete dun sa ating molds. Next naman po is air content. Ayun nga, meron na tayong temperature, concrete slump test, and now we have air content. So air entrained concrete is typically specified in areas of the country where frost-related damage can occur. The measurement of air content in fresh concrete of normal density is typically performed using the pressure method or ASTM C231. Another useful test is ASTM C173. However, the pressure method is frequently preferred because it is relatively fast. So, mas maganda daw gamitin yung ASTM C231. And bakit nga ba natin tinatest pa tong air content ng ating concretes? Siyempre sa other countries, no, malalamig. So, if na yung concrete natin is may void siya sa loob or kapag tumigas yun, pag halimbawa, for example, sa column, pag tinanggal natin yung tabla na nandun sa column, makikita natin na some ng ating concrete, makikita natin na may siya, parang sponge, parang may butas-butas. So, yun yung air content na dapat wala nun. Kasi pwedeng pag singitan nyo ng tubig, pwedeng mabasa yung loob ng concrete and then mabasa yung metal. And then kapag sa malalamig na lugar naman, pwedeng mag-yellow yun. So, maka-apekto yun sa ating concrete at lalong-lalo na dun sa bakal na nandun sa loob ng column natin. So, magkakaroon siya ng damage or crack. So, kailangan natin itest din yung air content ng ating concrete. And ito naman, you should begin the test within 15 minutes after obtaining the composite sample. So ito naman 15 minutes. Kung yung ating temperature and concrete stamp test is 5 minutes natin, after 5 minutes natin na-obtain yung composite sample, i-start natin sila. After naman dito na ma-obtain natin yung composite sample, 15 minutes tayo mag-start bago natin gawin yung air content. So start by filling the 0.25 cubic feet base of the air content test device. Meron tayong air content test device na gagamitin dito in 3 equal layers and rod each layer 25 times. So haluin natin using the rod. After rodding, strike the outside of the base with a mallet 12 to 15 times to close any air void. So pipikpikin natin yung gilid ng ating air content test device para hindi magkaroon ng air content or air voids yung ating concrete sa loob. And then after completing the 3 equal layers, strike off the bowl flush at the top to completely fill the 0.25 feet cube volume. At this point, it can be weighed as part of the calculation to determine the fresh concrete unit weight. So, dun sa ating air content test device, lalagyan muna natin yung base nun. Then after natin lagyan ng base, pipikpikin natin. Then kapag napikpik na natin, make sure na natin na walang void or air voids yung ating concrete dun sa base, dadagdagan na natin siya or pupunayin na natin siya ng concrete yung ating air content test device. And then, pwede natin tong gamitin or pwede natin tong timbangin to determine the fresh concrete unit weight. So next, latch the top of the air content test device over the base and fill the air gap between the top of the strap of concrete and the underside of the top of air meter with water. So lalagyan natin siya ng water. Yung after natin pippikin, after natin punuin yung ating air content test device, lalagyan natin siya ng konting tubig sa ibabaw. And then the meter top is then pressurized with the built-in hand pump until zeroed out or as calibrated. After a stabilization period, release the pressure in the top. So, bubuksan natin yung ibabaw ng ating air content test device. And then, read the air void content on the dial on the top of the meter. Subtract the aggregate correction factor from the dial reading and report the final value. So, may makukuha tayong reading dun sa ating air content test device. And then, isusubtract natin yon sa aggregate correction factor na meron tayo na nakuha natin dun sa reading. And then, sabi dito, report the final value. So, makukuha na natin yung ating air content. So, we also have testing tips about air content. So, a typical air content for concrete with a 3/4 inch maximum size aggregate is about 6%. And specified ranges in air content are typically -1.5% and +1.5% of the target value. So, yun dun lang nagre-range yung ating air content, no? Kapag may nakuha na tayong value. Ang range natin is -1.5% or 1.5%. So, yan yung testing tips natin for air content. So, next po, a type B pressure meter is used to determine the air content of normal weight concrete. So, ito yung dito sa picture, ito yung type B pressure meter natin na nakakuha natin kung ano yung air content ng ating concrete. So the air content is read at the dial, which is calibrated for each apparatus. The aggregate correction factor must be subtracted from your reading to obtain the net air content. So sabi ko nga kanina, isa-subtract natin yung nakuha nating reading dito sa ating air content device. And then, ma-obtain na natin yung ating net air content. So, ayun. Next naman is density unit weight. So after ng sampling, temperature, concrete slump test, and then air content, we also have density unit weight. So the density unit weight of concrete for ASTM C138 is measured using a type B pressure meter, yung pinakita ko nga kanina, to verify agreement with the approved project mix design. So ginagamit natin yung type B pressure meter para malaman yung density unit weight ng ating concrete, para malaman din natin na yung binili nating concrete is tama ba dun sa ating binili, no? Kung verify ba yun ng nasa agreement dun sa binilhan natin ng concrete, kung tama ba. So the information obtained Through this test can also be used to determine yield and relative yield, which helps you verify that you are getting the volume of concrete you ordered and paid for. So ayun nga, using the type B pressure meter, nakukuha natin yung density unit weight, and then malalaman natin kung tama ba yung binili nating concrete. So you can also use this data to calculate the air content of the mix. So ayun nga, pwede rin natin gamitin yung type B pressure meter and then yung ma-obtain nating data para mahanap natin yung air content ng ating concrete. So next po is density unit weight pa rin. The unit weight is determined by the formula below. Subtract the weight of the measuring base from the combined weight of the measuring base and the concrete it contains. Next, divide this weight in pounds by the volume of the measuring base cubic feet to obtain the density expressed as pounds over cubic feet. So yung D natin is yung density of the concrete, which isang unit is pounds per cubic feet. And then yung M sub C natin is weight of the measure holding the concrete. M sub M natin is the weight of the empty concrete measure or base of air meter. And then yung B sub M natin is yung volume of the measure, usually about 0.25 cubic feet for a pressure meter base. So, ito yung formula natin para mahanap natin yung density unit weight ng ating concrete. D is equals to M sub C minus M sub M then over B sub M. Density unit weight pa rin, we also have testing tips. Having the unit weight data gives you a third point to check a straight line. For example, when slump increases, the air content will generally increase. So sabi dito, ang slump natin and ang ating air content is directly proportional. If the slump increases, the air content will also increase. If significant, look for the unit weight to decrease measurably. If that is not reflected in the test results, keep an eye on the testing and examine the data, procedures, or reporting accuracy. So, kung yung unit weight daw natin is nag-decrease, so kailangan i-check natin or tingnan natin yung ating data, procedures, or reporting accuracy base dun sa mga nakuha nating test kanina. Next naman po is the molding test specimens. So, these are the requirements. Mold specimens promptly on a level, rigid, horizontal surface, free from vibration and other disturbances, as near as practical to where they are to be stored. So, yung molding test specimens natin kanina, yung sinabi ko ngayon, lalagyan natin ng concrete. So, ito yung requirements niya. No? Dapat nasa horizontal surface siya and free from vibration so that talagang walang makaka-apekto dun sa concrete na nasa loob ng ating molds. Second is immediately after being struck off, cover the specimens and move to the place where they will remain undisturbed for the initial curing period. Third is if specimens made in single-use molds are moved, lift and support the specimens from the bottom of the molds with a large thrower or other flat device. So kung ilipat natin yung ating specimens, gagamitan natin siya ng large trowel para dun sa ilalim ng ating molding test specimens or yung base niya. Kung gusto natin ilipat, lalagyan natin ng flat device dun sa ilalim. So ayun, yun lang po. Thank you very much. Thank you for your listening.
Good day! So, ang last topic natin is curing, transportation, and report of concrete test specimens. So, pag sinabi natin curing, yun ay yung pagpo-provide ng specific moisture, temperature, and time para maalaw yung concrete na ma-achieve yung desired properties mo para sa kanya. So, iba siya sa drying ng concrete kasi kapag sinabi natin drying, kumbaga hayaan mo lang siya na matuyo para ma-achieve mo yung gusto mong moisture and properties ng concrete. Pero kapag sinabi natin curing, ikaw mismo yung magpo-provide, ikaw yung magko-control ng dapat na moisture and temperature, and ikaw din yung magsiset ng time sa kung gaano mo katagal gustong mag-cure yung concrete para makontrol mo yung result ng properties ng concrete. So, sa curing, merong dalawang type, standard curing and field curing. Ang major difference lang naman nila ay kapag sinabi nating standard curing, from the word standard, meron kang susundin na standard moisture and temperature and time sa pagko-cure ng concrete test specimen. Kapag naman sinabi nating field curing, kung i-cure mo siya sa lugar kung saan mo itatayo yung structure na paggagamitan ng concrete. So, halimbawa, itatayo mo siya dyan. Dun mo na rin i-cure yung mga concrete test specimens. Kaya yung mararanasan nilang moisture, temperature, humidity, yun na rin yung mararanasan ng final product. So, kumbaga parang hinahanda mo na sila sa kahaharapin ng final concrete na gagamitin mo. So, ang pag-cure ng concrete ay ginagamit para itinetest kasi to, yung concrete test specimens. Tinetest sila para malaman natin yung specified strength, yung adequacy ng mixture proportions for strength, quality control, and ganun na rin para ma-determine natin kung yung structure ba ay capable para magamit para magamit siya sa service, at kino-compare din yung test result ng standard cured specimens or sa test results ng various in-place test methods, at para malaman din yung adequacy of curing and protection of concrete sa structure or pag-form ng or sharing ng removal time requirements. Yun. So, sa standard curing, merong ng standard process, merong standard moisture na kailangan. So, sa pag-i-store daw ng standard curing test specimens, kailangan yung supporting surface na kung saan yung specimens ay i-store, kailangan level siya within 20 mm per meter or 1/4 inch per feet. Kung yung specimens naman ay hindi minold sa kung saan naka-receive siya ng initial curing, kailangan daw yung specimens move siya doon sa location ng initial curing no later than 15 minutes after matapos yung molding operations. Kapag naman yung specimen ay nasa single-use mold ay nalipat, kailangan isusuportahan yung ilalim ng mold. And kapag naman yung top surface ng specimen ay kumbaga nagalaw or naistorbo siya while moving pag-move ng place mula sa initial storage, kailangan i-refinish lagi yung surface kapag nagagalaw yung top surface ng specimen. So, sa initial curing, kailangan i-store daw yung standard cured specimens sa loob ng 48 hours after molding para ma-maintain yung specified na temperature and moisture conditions. Para naman sa mga under specified temperature, para sa mga concrete mixture na may specified strength na less than 40 MPa or 6,000 PSI, kailangan ma-maintain yung initial curing na temperature between 16 and 27 degrees Celsius lang. Kung yung concrete mixture naman ay may specified strength na 40 MPa or 6,000 PSI or mas mataas pa doon, kailangan yung maintained na initial curing temperature natin ay between 22 to 26 degrees Celsius lang. Sinasabi din dito na note, kailangan i-shield natin yung specimen from direct sunlight or direct na paggamit ng radiant heating devices. Hindi naman sa sinasabing bawal, pero kailangan i-avoid natin na direct silang maka-apekto dun sa specimen natin kasi may iba siyang nagagawa. At kailangan din nire-record natin yung minimum at yung maximum temperature na na-achieve sa bawat set ng specimen during initial curing period. Ayun, so kailangan i-store din natin yung specimen sa environment na nakokontrol niya na yung loss of moisture. Kailangan huwag natin i-store sa environment na prone sa loss of moisture. Ayun. Meron tayong mga notes sa under specified temperature, kagaya ng hindi daw sapat na cover mo lang yung specimen. Kailangan para ma-maintain yung environment na required sa initial standard curing, meron pa tayong ibang dapat gawin. Halimbawa, pwede na tayong gumamit ng ventilation, ng ice, ng cooling devices or heating devices, kagaya ng electrical resistance heaters or light bulbs. Pero, iba pang method, pero kailangan hindi sila direct dun sa specimen. Pero yun, para makontrol natin at makuha natin yung satisfactory temperature environment, pwede tayong gumamit nun. At tatandaan din natin na mahalaga yung specific temperature sa specified na strength ng concrete mixture. Kasi kapag halimbawa, mas mababa yung temperature na ginawa mo, ginamit mo dun sa pag-cure ng concrete, pwedeng mababa din yung early age strength test result. Kapag naman masyadong mataas yung temperature mo, masyado ring mataas yung test result. So, malaki yung effect nun sa test results ng concrete test specimens natin. Ayun. Para naman ma-achieve natin yung satisfactory moisture environment, pwede tayong gumamit pwede nating i-immerse yung molded specimen sa tubig, basta meron siyang plastic lids. Pwede din naman natin silang i-store sa container or kahit anong enclosure. Pwede din natin silang i-place sa damp na sand pits or i-cover lang sila ng plastic lids, tapos yun na yun. Pwede din natin silang ilagay sa loob ng plastic bags or i-cover natin siya with wet fabric. Pero yung pinaka-madaling method para ma-maintain yung moisture and temperature sa initial curing, yung pag-i-immerse ng specimen sa water basta meron siyang plastic lids. Ayun. So, sa final curing naman, for cylinders and beams, ayun, sinasabi dito na sa completion ng initial curing at within 30 minutes matapos na ma-remove yung molds, kailangan i-cure yung specimens with free water na merong temperature na 20 degrees Celsius or 73.5 degrees Fahrenheit. At kailangan gagamit din tayo ng water storage tanks or moist rooms na makakapag-comply sa requirements ng specification ng ASTM C511, maliban na lang kung yung capping ay with sulfur mortar capping compound and immediately prior to testing. Kapag ganun daw yung case na when capping with sulfur mortar or capping compound, kailangan yung ends ng cylinder ay dry enough para ma-preclude yung formation ng kahit anumang steam or foam packets na sa ilalim. Ayun. So, sinasabi din sa final curing ng cylinders na yung period ay kailangan ng final curing ay hindi lalagpas ng 3 hours. Ayun. Tapos, temperature, sabi dito, temperature is not required provided free moisture is maintained on the cylinders and the ambient temperature is between 20 to 30 degrees Celsius. Ayun. Sa mga beams naman, kapag mag-final curing, halos kaparehas lang daw ng pagpa-final curing ng cylinder. Maliban na lang, yung beams ay kailangan may store sila sa water saturated with calcium hydroxide. So, sa cylinder kasi, iba. Tapos, ayun din, ganun din yung temperature, 20 degrees Celsius or 73.5 degrees Fahrenheit. At, kailangan at least 20 hours prior to testing yung pagpa-final curing ng beams. Yung pagdadry naman ng surface ng beam, kailangan may iwasan yun between removal from water storage and completion of testing. Ayun. Sa field curing naman, kapag field cure ng cylinders, kailangan yung cylinders ay i-store sa structure as near to the point of deposit of the concrete represented as possible. Yun yung sinasabi ko kanina. Kailangan din daw, syempre, po-protect lahat ng surface ng cylinder sa mga kahit anumang elements na hindi dapat masama dun sa concrete mixture natin. Kailangan din, syempre, meron ding same temperature and moisture environment na mararanasan yung cylinder dun sa structural work yun. So, kung saan nga siya itatayo. At kailangan itetest yung specimen sa moisture condition resulting from the specified curing treatment. Para ma-meet yung conditions na sinasabi natin dito sa field curing, kailangan yung specimens na made for the purpose of determining kung yung structure ba ay capable of being put into service, kailangan ma-remove yung molds at the time na ni-remove yung sa time of removal of formwork. Yun. Sa beams naman, halos ganun lang din daw. Kagaya sa cylinder. Yun. At the end of 48 hours after molding, kailangan tanggalin yung molded specimen sa storage location at tanggalin siya sa mold. So, ililipat mo muna siya bago tanggalin sa mold. Sabi rin na store specimens representing pavements of slabs and grade by placing them on the ground as molded with their top surfaces up. Ayun. Sinabi din na yung i-bank daw yung sides at yung ends ng specimen with earth, yun ng lupa or sand na kung saan mapapanatili siyang damp para yung top surface ay exposed sa specified curing treatment. Sabi din, other specified process sa pag-field curing ng beams, kailangan same temperature, ayun, and moisture nga sa environment ng structure, at sa end ng curing period, kailangan iiwanan natin yung specimens dun sa exposed na weather ng lugar na yon, ng location na yon. After naman nun, tanggalin natin lahat ng beam specimens from field storage at i-store natin siya sa water saturated with calcium hydroxide, kagaya nung kanina sa standard curing, so kapareho lang din siya. At 4 hours then immediately before time of testing para ma-ensure yung uniform moisture condition mula sa specimen to specimen. At kailangan mag-observe din natin yung mga precautions para mag-guard natin yung specimen natin from drying between time of removal from curing to testing. Yun. And next naman natin is yung transportation of concrete test specimens. So, sinasabi natin dyan na yung specimens kailangan hindi sila matatransport until at least 8 hours after final set. At yung transportation natin hindi pwedeng lumagpas ng 4 hours. During transporting natin ng concrete test specimens natin, kailangan maprotektahan pa rin natin yung specimens. Kaya kailangan natin meron tayong suitable cushioning material para ma-prevent natin yung damage from jarring. At kapag naman cold weather, yun, kailangan protektahan din natin yung specimens natin from freezing sa paggamit ng suitable insulation materials. Yan. And lastly, sa ating report ng concrete test specimens, kailangan i-report natin itong following information sa laboratory na magte-test ng specimens na kinure natin. So yun, kailangan kasama yung identification number, location ng concrete na represented by the samples, date, time, and name of individual molding specimens, slump or slump flow, air content, and concrete temperature, test results, and results of any other test on the fresh concrete, and any deviations from reference standard test methods. At ganon din, kailangan is include din natin sa report yung curing method. Yan. Para naman sa standard curing method, kailangan i-report natin yung initial curing method with its maximum and minimum temperature at ganoon na rin yung final curing method. Kapag naman field curing method yung ginamit natin sa pag-cure ng concrete test specimens natin, i-report natin sa yung location kung saan natin in-store yung mga specimens while curing, yung kung paano natin sila pinrotektahan from any elements, ano yung mga ginamit nating materials, ganyan. Kailangan din natin i-report yung temperature and moisture ng environment at yung time ng removal natin ng specimens from molds. And yun lang yung ating top for concrete test specimens. Thank you!